Welcome back. So I've got a couple more problems for you here, and we're using the exact same questions. The difference is the relationships we're going to look at now are non-proportional, and we'll talk about what that means as we look at the problems. First of all, let's look at our independent and dependent variable here. We have for x the hours that a pool is draining, and for y the volume of the pool. Oop, I forgot my label. That should be gallons. So this is the number of gallons of water in that swimming pool. Well, let's look for our y-intercept first. When x is equal to 0, what's y? Nice job. When x is equal to 0, y is 15,000. So we could say b is 15,000. We could write the coordinates 0, 15,000. That's our y-intercept. And what do you think that means that the y-intercept is 15,000? Yes, it means that the pool starts with 15,000 gallons of water. Okay, now if we were to graph this relationship, let's talk about what the slope would be. I'm just going to use my first two values again. They're perfectly fine. I'll use this row and this row. So we have x1, x2. We have y1, y2. Let's use our slope formula. All right, so be sure you're doing your arithmetic carefully here. You are going to get a negative result, negative 2,400 over 2. That's the same thing as negative 1,200 over 1. And what does that mean? Well, remember we're talking about a pool draining water. We have hours and we have gallons. So what this means is the pool drains 1,200 gallons an hour. And now we have everything we need in order to write our equation. It's still going to be y equals mx plus b. This time our slope is negative. It's negative 1,200. And we have a y-intercept that's not 0. It's 15,000. So this would be the equation of our relationship that's in the table here. And we can clearly see our slope and our y-intercept. Let's take a look at that graph. So the pool started with 15,000 gallons. And now let's look at our slope. I find it easier to think about when I have my labels here and we can see what's going on. We can see it goes down and it goes over. It goes down and it goes over. That's why it has a negative slope, because it's going down and over. Okay. And as it goes over 2, it's going down 2,400 for every one of these steps. Down 2,400 and over 2. And really, that's the same as going down 1,200 and going over 1. That's an equivalent slope, and those points would all be on our line too. So that's how our graph ties back to our table. I've got one more that I want to look at together, and then I've got a couple for you to do on your own. This is another table where we can't see the y-intercept right away. But I bet you guys could figure out what it would be. Let's actually start with our y-intercept this time. Let's see if we can find a pattern in the table and use it. Why don't you pause the video for a minute and see if you can figure out how the x and y values are changing as we go through the rows. Nice work. So we can see that in this table, each row, the x values increase by 4, and each row, the y values increase by 800. Okay. I want to work back to where my x value is 0. I want to work backwards to where x is 0. Well, 0 plus 4 is 4. How can I figure out what my y value would be? Well, I know whatever it is, if I add 800 to it, I will get 1,200. 1,200 minus 800 is 400. So that means that 400 is my y-intercept. All right, y'all, what do you think that means? We're talking about the months that somebody spent saving and their savings account balance. So this means that their account started with $400. Now let's think a little bit about the slope. I'm just going to use my first two rows again, although really I can pick any two rows. Let's label those values. And why don't you see if you can calculate the slope of this one on your own? I think you can. Nice work. So the slope is 200, and it's a positive 200. So what that tells us is that each month, this person adds $200 to their savings account. So I'm going to say 200 added each month. Now, you know, there was another way that you could have gotten that slope of 200 as well. If you wanted, since we identified the, we were increasing by 800 in the Y values each row, and we were increasing by 4 each row in our X values, we could have just done 800 divided by 4 using that, just by comparing two rows. That's possible because what we're looking for is a constant rate of change. So that was another way to get the slope of the line if we were to graph this. Let's do the easy part. Y equals mx plus b means y equals 200x plus 400. And there is your graph. We started with $400. It's right there as our y-intercept. And let's look at our slope. It's easier when my points are labeled, so I went ahead and did that. Let's take a look. It looks like we went, oops, I had an eraser instead. Let me get out my highlighter. There we go. Okay, so we went up 800 and over 4. We went up 800 and over 4. Up 800 and over 4, up 800 and over 4, all the way across our staircase. So that's where we can see our slope in the graph. And remember, 800 over 4 gave us our slope of 200. We're adding $200 to this account each month. Down below, there are a couple problems here for you to work. Give them a try. Remember, what you're looking for is the slope and the y-intercept, and you also want to think, what do those tell me about this situation? Thank you guys for watching.